Hello everyone, I'm very happy to be here, and today I'm going to talk about NgRx SignalStore. We will see some story about how it started, how the initial idea started, and also see SignalStore in action. But first, let me briefly introduce myself. My name is Marko Stanimirović. I work as a principal front-end engineer at a company called Swiss Marketplace Group. Besides that, I'm core member of NgRx team, GD in Angular, and organizer of Angular Belgrade Group. And yeah, if you have Twitter, you can find me there by using my handle at Marko STDev. So the first question for today, what is NgRx SignalStore? And by definition, we can say that SignalStore is a reactive state management solution that provides native or first-class support for Angular signals. And it's built with some key principles in mind. We try to provide simple and intuitive APIs, to have the straightforward APIs that are easy to use and self-descriptive. It's also lightweight and performant. So based on used APIs, because it's reshakable, the size, the participation of signals, NgRx signals package in the final bundle can be from 300 bytes to maybe 2 kilobytes. It's also, the idea is to, when we use NgRx SignalStore, to define our state management logic in a declarative way. NgRx SignalStore is also modular, extensible, and scalable. So with SignalStore, we have the ability to define independent building blocks that can be reused together or independently to build extensible and scalable applications. NgRx SignalStore is opinionated, but flexible in the same time. So we try to find some kind of sweet spot between opinionated and flexible API. And as Manfred mentioned, it's type safe. So we try to provide the API that will help us to find bugs in the early phase at compile time instead of runtime. And let's now see how we can create a simple signal store. So to create a signal store, we can use SignalStore function from NgRx signals package. It works as a pipe from RxJS. So it accepts a sequence of SignalStore features and returns a dynamic service. In other words, it returns a store as a result. As you can see, I used Pascal case here, right, to do store instead of camel case because it returns a service, not the instance of the store. So as I mentioned, it accepts a sequence of features. And the first base feature is with state. By using with state, we have the ability to add state slices to our store. So the with state accepts initial state as an input argument. The next base feature is with computed. By using with computed, we can add computed state to our store. And you can notice that with computed accepts a factory as an input argument. And input argument of this factory will be previously generated signals for every state slice that we define. In this case, we define the to-dos array. So under the hood, SignalStore will generate a to-dos signal that can be used here, for example, to create computed to-dos signal, completed to-do signal, sorry. And the last base feature is with methods, and it has very similar signature to the with computed, but instead of computed signals, here we want to define to return a methods as a result. So in this case, we will add to-do method that will update our state. And to update the state, you can notice that we are using another function called patch state, which is again a standalone function that accepts a store as a first, and it also accepts a sequence of partial states or partial state updaters as REST arguments. We will see that later in action. So when we want to use a store, we can provide it as any other service. I told you it returns a dynamic service as a result. So we can provide it at the component level if we want to manage the local state and then inject it inside of our component and use it as any other service. So we can get the signals that we created or that SignalStore generated for us, or use the methods that we defined. But you may be thinking, okay, why functional? So most of the, especially, let's say, local state management solutions are class-based so far. And to find the answer of this question, let's see some limitations of the class-based state management solutions. So I worked with component store a lot, and I faced these limitations that we'll now see, but they are not only related to the component store, but to any class-based state management solution. So the first one is typing. It's not possible to define dynamic class properties or methods that are strongly typed. What I wanted to achieve before is, because if you use, can you raise your hand if you use component store before? Okay, cool. So with component store, we extend the base class and pass the initial state to the parent constructor. And what is possible to do at runtime is to take the initial state and to automatically generate the selector for each component store state slice. But the problem is to provide a type for that. We cannot dynamically add properties or methods to the base class and have that base class strongly typed. That's the problem. Next problem is tree shaking. So unused class methods won't be removed from the final bundle. So in case of component store, we have some utilities: updater, effect, patch states, set state, etc. And if we don't use updater, for example, it will end up in the final bundle. The next problem is extensibility, because multiple inheritance is not supported, at least out of the box, right? The next problem, the next limitation actually is modularity, or scalability. We cannot split selectors, updaters, and effects into different classes. I mean, it's possible, but it's not provided out of the box. So then I ask myself, okay, should we consider a functional approach? And yeah, I think that we should. We should consider that, so we should provide a state management solution that solves the limitation that we just mentioned, but we should also provide a state management solution that provides a native or first-class support for new reactive model that Angular framework provides. And let's now see the SignalStore in action. So here we have a quick demo. You can find it on my GitHub profile. You can go to repositories, and here it is, NgRx Signals example. This is the name. Here we can find the source code that we will see today. And the first example is very simple. We want to create a counter store. Here we can see the component. Let me just start the development server. So here we can see the component where we want to display the count, which is a base state. We also want to display double count, derived state or computed state. And we want to have two methods, increment and decrement, to increment or decrement the count value. And here in the counter store, we want to define a signal store that will do this, perform these operations. So I will export a new const. I will name it counter store. And as we saw from the slides, we can use SignalStore function. This function is imported from the NgRx Signals package. And as we mentioned, it acts as a pipe, so it accepts a sequence of SignalStore features. The first feature that I want to use here is with state. Is an input argument I want to provide count 0, like this. The next thing is to define a derived or computed state. So we can use with computed. With computed accepts a factory function. And here we can notice one interesting thing. So it generates, you can see that it generates a count signal, which is type of signal number based on state that we previously defined. If I define, for example, M here, and say that this is 1, here we will have two signals. We will have count and M. But there is one more thing. It will generate deep signals. So if we have nested state slices, it will generate nested signals for each state slice. If I do something like this here, M as T1. So now here we will have M, which is, you can see the type is a deep signal. And let's Let's quickly inspect the, so result is m. So here we can access m dot, you can see we can access dot s, which is again type of deep signal. We can get its value by executing it as any other signal. So this is now t number. But if we want, we can also access the t, which is now the signal type of number, right? So that's another feature. SignalStore will automatically create deep signals for us. Okay, we don't need this. In this example, we only need the count state slice. So let's now create a double count computed signal. The next thing is to create increment and decrement methods. So I will use with methods feature. And we'll have increment and decrement. Okay, Copilot is not right here. So what we need to do, we need to use patch state. I will remove this and define them. I will not use I will not use row functions. I will use methods like this. I mean, there is no difference, but I prefer this way for some reason. So here we can use patch state function. We can see patch state is imported from the NgRx signals. And now we need to pass the store as a first and sequence or updater or partial state as REST arguments. So to get the store, we will get it here as an input arguments of with methods feature factory. So here, if we inspect the type, you can see that here we have a count, state slice, double count computed signal, and this state signal is important if we want to update our state. We don't need to access it. I mean, we cannot, it's a private, we cannot access directly, but we need to pass the store as an input argument of patch state, and under the hood, patch state will take this state signal and update our state. As the next argument, what we want to do, we want to increase the count, so as a partial state, we can pass count and say store dot count like this, +1. This is the first way. The second way can be to pass. So for decrement, let's use the updater function. So we can do also something like this. Okay. Copilot is right this time, but instead of count here, this is how it works. So yeah, we now define the counter store, and let's try to use it inside of the counter component. So the first thing is to provide it, because we want to have to manage the local state, to provide a count store at the component level, so we can add it to the provider's array of counter component. Counter store, like this. Then what we can do, we can inject it. So we can use the inject function. Store is equal to inject counter store, like this. And then for count, we want to display store.count, and for double count, store.double count, like this. When increment button is clicked, we want to call store.increment method. And when decrement, we want to call store.decrement. So as I told you, counter store is a service, so we can provide it and inject as any other service. Let's quickly inspect its type. So I'll quickly create a constructor here. If we say store dot, you can see that, let's store dot count, for example. Okay, we need to use this here. We can see that it's a signal number. Here we also have, so store.double count. We also have increment and decrement methods that we defined. The next example that I want to show you is how we can create custom features. So here we have the same example. We have SignalStore. We have this with state, with computed, with methods features that we use. But what if for some reason we want to add this logic to multiple stores? To have increment and decrement methods and count as a state slice into multiple stores. So for that, we can create a custom features that provides this and reuse this feature in any store where this logic is needed. I also forgot to mention another base feature that SignalStore provides, which is with hooks. So with using with hooks, we can add a specific logic when our store is initialized. So here you can see the onInit, or when the store is destroyed, we can use onDestroy and provide some logic when our store is destroyed. But let's now see how we can create a custom feature. So I created a file and name it counter.feature.ts. So here we can export a new function, and we can call it with counter. So this feature should provide a counter feature. I will return here the result of function called SignalStore feature. So not SignalStore, but SignalStore feature. And SignalStore feature has the same signature as SignalStore. So it accepts a sequence of base or custom features. What we can do here, we can just, for example, copy this part, these three features that we defined, paste it here. So now every time when we include with counter into any store or any custom feature, we will get count state slice, double count computed state, increment and decrement methods. So here what we can do now, we can call with counter like this. And you can see that we don't have compilation error anymore. Double count is available again. It's type of signal number. In the same way, here we can access increment or count if we need it, because these APIs are provided by the custom with counter feature, right? And there is another thing here that is different from the previous example. So by using SignalStore, we also have the ability to define a store as a singleton to provide our store at the root level. If we want to have a global state, if we want to manage the global state with SignalStore. The next example is how we can integrate RxJS inside the SignalStore. So I told you SignalStore provides native support for signals. It has RxJS as an optional dependency, which is, by the way, one of the goals that Angular teams has with Angular, to have RxJS as an optional dependency in the future. But it provides the integration for RxJS, because RxJS is still a great solution when we want to handle asynchronous side effects. So here let me quickly show you the example. So we have a users component. It's very simple. We have the search box and we have the list when we want to display the list of users. So every time when query is changed, what we want to do, we want to send the HTTP request to our server to fetch users by query and to update the users array that will be displayed in this presentational component. We also have the isLoading flag to indicate the loading. So when update query method is called, query will be updated. But what we now want to do is every time when query is updated, we want to fetch users from the API. So we can define a new method. We can call it load users by query, like this. And this will be Rx method. So I'm now importing Rx method function from NgRx signals / RxJS interop sub package or plugin. So NgRx signals package provides plugin for RxJS interoperability or integration. Rx method, by the way, is componentStore.effect. It provides the same API. If you use componentStore.effect, you know that this function actually returns a new function that can be called with a static value, with signal, or with observable. So inside of Rx method, we will see right now, we can define the reactive chain of RxJS operators that will be executed every time when Rx method is called. So here, as an input argument, we need to specify the type of our input argument. As a generic here, it will be string. because query is type of string. And then here we can use pipe. Copilot is wrong all the time. Anyway, so first thing that we want to do here is to add, for example, let's add debounce time, 300. Let's add distinct until changed. And then let's set loading to true. So I will add tap and call patch state. OK, it's right this time. Call is loading to true. And then after that, I want to call switch map like this. And I want to use users service.get by query in order to fetch queries, to fetch users, sorry, from the API. But now the question is how to get this user service. The thing is, all base features, all the features that SignalStore provides are executed inside of the injection context. So we can inject our user service here. I can say user service is equal to inject users service. This is the service that I previously defined, and it has a get by query, a method that returns observable of users. So we can now use get by query. The query, we will get the query here as an input argument. So we can pass it here. Last but not least, when we receive the response from the API, we want to update our state, right? So I will use tap response operator. Tap response operator is exported from the NgRx operators package. And this is another new package that provides reusable operators that can be used across NgRx packages. So tap response was previously exported by the NgRx component store. And it is nothing else than tap, but under the hood it has catch error, and it will return an empty observable if error happens. So this provides the ability to, so it actually, we don't need to resubscribe when error happens by using tap response. So here, if everything is OK, I want to say, let's remove is loading. Only this. I want to add users, update the users state slice. If error happens, yeah, let's just log the error. But we also have here the finalize callback that will be executed in both cases. So if we get success or error response, finalize will be executed. So in that case, we can set loading to false like this. And now, as I told you, Rx method returns a method or function. And now we need to call this method. So I will use another base feature with hooks, because what I want to do, when this store is initialized, I want to call the load users by query method that I defined here. And if we pass the value like this, because query is a signal, you can see, if we pass the value like this, it will be executed only once. But if I pass a signal, so reference to the signal as an input argument of this Rx method here, then this chain of operators will be executed every time when query signal emits a new value, when the value of this signal changes, actually. Which means that every time when update query is called, query will be updated, query signal will emit a new value, and then this load users by query method will be executed. OK. The last example is using entities plugin. So NgRx Signals package also provides another plugin for managing entity state. And it's very inspired by NgRx entity package. So you can see here with entities. This is another custom feature, but it's provided by the core package. With entities feature, as we created with counter, and we added count-based state completed, or no, double count computed state and increment and decrement methods. In a similar way, with entities feature, we'll add entity map and IDs as a base state, and it will also add list of or array of entities as computed state. So now what we can do here in our store, let's quickly inspect what we have here. You can see that we have signal that contains array of entities, array of IDs, and entity map as another signal. Entities plugin also provides updaters. But if we compare these updaters to the NgRx entity package, they are tree shakeable. So here you can notice when we want to update the state, we are using add entity updater that is provided by the entities sub-package. We don't have adapter and then dot something. Why? Because we want to build tree shakeable APIs. So in this case, only updaters that are used in our source code will end up in the final bundle, unlike NgRx entity package. And yeah, let's quickly see the component. It's very simple. So we have add to do presentational component and we have to do list. Let's see if our code compiles. And open. See how it works. So yeah, counter, it should be fine. This is the same example. We have RxJS integration also. So yeah, we have the search here. If I type John, for example, you can see the loading, and then the result is displayed. If we go to the entities page, here we can add entities. And yeah, this is the picture from screenshot from NPM registry. So maybe 10 days or 2 weeks since we released the first stable version of NgRx Signals, it reached the first milestone, 1,000 downloads, weekly downloads. And I also checked the NPM this morning. I think it's right now around 2,000 weekly downloads. It's also important to mention that NgRx Signals package is inspired by some existing state management solutions. It's inspired by NgRx Store, NgRx Entity and Component Store. It's also inspired by RxJS. If you took a look at the RxJS version 8, you can find the Rx function. And patch state works in very similar ways. So Rx function accepts observable as first and sequence of operators as REST arguments. In case of patch state, for example, we pass the store as a first and sequence of updaters as REST arguments. It's also inspired by ELF. And I used Vue.js in the last couple of months a lot, so I took some inspiration from Vue.js Pinia as well. I also want to say big thanks to these amazing people who helped me with implementation, suggestions, challenges, and everything that was needed to implement these state management solutions. So my teammates from NgRx team Brandon and Alex. Also big thanks to Gabriel, to my former manager Phil, and to friends from Angular Architects team, Rainer, Manfred, and Mike. If you want to follow us, you can find the NgRx official account on Twitter, NgRx_IO. We also have the profile on LinkedIn, NgRx. If you have any question or you want to help others, you can join our Discord server on the following link, discord.gg/NgRx. We also have the official docs, ngrx.io, official blog, and there is one new thing here on this link. You can find the workshops that NgRx team will conduct in January and February. There are 3 days workshops about global store, component store, NgRx Signals, so you can pick the workshop that you want. Also, this is the link of our GitHub profile, so if you want to contribute or if you want to see how NgRx Signals, for example, is implemented, you can go there. In the end, I also want to mention that in May next year, we are organizing Angular conference in Belgrade. So you are more than welcome to join us. You can find more information by visiting our website, angularbelgrade.org. And that's it. Thank you very much for attention. Thank you.